Morning, grade 8s. Right, so for today we'll be working with our monomials and the product, and we'll see what happens if we also then work with division. So this is from our Mind Action series books, and we are working with topics where we need to combine our understanding of the terminologies that we've learned, the coefficient, the variable, the exponent, but this time we're also applying our exponential laws. So I'd like to just first make a note of that. When we work with our exponential laws, we need to make a brief summary just to remind us, because here we work with a lot of product over a bracket, into a bracket, and we need to adjust and work accordingly. Right. Okay, so here we've got the instruction to simplify, and we want to just quickly give ourselves a brief review of all those important exponential laws that we've learned. Right, with exponents we have certain rules, the same base to the power, the same base that I've multiplied to the power, I need to add the exponents. And then if I divide, I need to subtract the exponents. The one that we will focus on today is the one with our bracket. It's one where we have something to the power a to the power of n, bracket to the power of m, and now we will multiply the power. Okay, so they don't all look as simple as this one because there's a lot going on in the brackets. So if we look at our example here, we see we have to apply a little bit more with regards to signs as well. So let's look at number A. Number A says minus 3 x to the power of 3 to the power of 4. And I want to make a clear definition here between what I have as a coefficient and then what I have as a variable. So we need to apply the law to the coefficient and to the variable carrying its power. So very important, minus 3 takes the power of 4, and I apply that to x to the power of 3, and I times its power by 4. So there's a little power 1 standing there. 4 times that 1, so that becomes a negative value to the power of an even value, this even value that we know of. And we know that our answer has to be positive then. So the negative times the negative times the negative times another negative leaves us with an overall positive answer. And 3 to the power of 4 is 81. And then here I have 4 times the power of 3 because of the x carrying the power of 3. And my answer becomes x to the power of 12. Okay? So we need to remember our laws. Where we learned this in the first term, we said, let's make it easy and say a negative 1 to the power of an even value will always be positive, and a negative 1 to the power of an odd value will always be negative. So that's the rule that we're applying there. Right, let's look at number B. Number B gives us minus 3 x to the power of 3 y to the power of 3. Once again, I'm going to encourage you to use your little arrow. This is minus 3 to the power of 1, and this is x to the power of 3 and y to the power of 1. That power of 3 needs to be multiplied with each power. Each base carries its own power. Therefore, my answer here, just to be safe, you may say minus 3 to the power of 3 just to be able to sort that sign out. And then we continue with the x, 3 to the power of 3. And then I have my y to the power of 1 to the power of 3. So I'm actually just expanding. What I'm doing here is I'm expanding it to show you how each base will carry its individual power. And what we have now is a negative to the power of an odd value has a negative answer. 3 to the power of 3 is 27. X to the power of 3 times 3 becomes 9. Y to the power of 1 times 3 becomes 3. Okay, so I trust that you're all with me on that. Now, if we look at a negative sign outside of our bracket, we can see with number D, for example, you have that power not affecting the negative outside of the bracket. Let me just highlight that for you there. Number D. So that negative there has nothing to do with the power of 2, okay? So watch out when you get given questions like that. That negative 3a is to the power of 2. So our important section here is this right here. In fact, we are applying the rules of BODMAS once again because we have to first sort out the bracket, okay? This negative here stays. It stays there. But what I do in the bracket is I simplify. And now my negative 3 to the power of 2 becomes negative 3 times negative 3. That's the negative 3 to the power of 2. Becomes a positive 9. And the a is squared. My final answer is a negative 9a squared. Okay. Right. Let's just have a look at number E. We still have product here, but we need to check very carefully because we have product. That's 3p to the power of 3 is squared. And then we have that product with the product of 2p squared to the power of 4. So make sure that you apply what we did here to each bracket individually, and then you will multiply the result, the product that you get from 3p to the power of 3, which is squared, you'll multiply that with the next product. So please be careful to do it individually. Okay, and then if I look at number F, let me just do that one here. I also see again, very careful here to work with our bracket first. We leave that negative there. Okay, and here we have a 2 in front of the bracket. Okay, so let's first do the product of the brackets because that's what we're going to need to see. Our eye needs to be guided by leaving this negative sign outside the final bracket and then this 2 outside the final bracket. That means I am left with a negative. And now minus 2 to the power of 4. I'm going straight into the bracket. M to the power of 8. I keep my plus, which is originally plus 2. And I simplify my bracket first. 2 to the power of 2. M to the power of 8. Right. And now let's quickly jot down our rules again if we've forgotten them. 2 to the power of 4 is not 2 times 8. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. And I apply my rule here. I have a negative 2 to the power of 4. Right, which then leaves me with keep that negative outside your bracket and first sort out negative 2 to the power of 4. Right, now what we have here is because it was originally outside of the bracket, that 4 will affect your negative, okay? So it's negative times the negative times the negative times the negative ultimately gives you a positive 16. M is to the power of 8 plus, let me first simplify what I have in my bracket. 2 to the power of 2 is 4, m to the power of 8. My final answer, minus 16 m to the power of 8 plus, now I may multiply the 2 with the 4, which is 8, m to the power of 8. And what do we have here? We have like terms. So when we have like terms, we are able to add. And in this way, we have a negative 16 plus 8. I am on my number line. I'm very negative. I become less negative. And I still have my m to the power of 8. Right. So that's basically going through all those rules that we learned in the first term. And we need to work with them very nicely so that we can apply all the rules to the product and the division. Okay, now that we've got that out of the way, let's look at the division part of things. So here we are going to focus mainly on the fact that when we have one term, we are allowed to simplify. So right in the beginning of the chapter, we started with the idea of what are monomials. Monomials are those terms that have product and division. Product and division makes one term, right? So let's get this here and let's quickly just refresh our memory. We had x times y becomes xy, that's one term. But as soon as I have x plus y, the fact that I have a plus there makes it two terms, a binomial. So we first need to see, especially with this number b, I'm jumping straight into the one where we make most mistakes. We are not allowed to cross cancel or to cancel anything when we still have pluses and minuses separating terms. So we have to be very careful here. We have to first simplify, in this case, the numerator, and then we can simplify by cancelling numerator and denominator. Whatever bases are allowed to perform this right here, where we have the law where we divide. But you're only allowed to do that when you have one term. So always check that any plus and negative, plus minus signs are first simplified. So you are allowed to simplify your term so that you have one term to work with. Okay, great. So let's just continue with number b. I can finish that off. So when we have x to the power of 3 plus x to the power of 3, I ask myself, is that like terms? And yes, I may add them, which gives me 2 x to the power of 3's. Okay, let me just quickly put that on the side there. Extremely important. X plus x is equal to 2x. But x times x is equal to x to the power of 2. Okay, and if we want to add another one in there, we can also actually add x divided by x is 1. So please don't forget about these important aspects. Back to number b, 2 to the 2 and x to the power of 3 over 3 x y. I am allowed to now cancel. I am allowed to cancel, right? Because I have the same base here. I take x to the power of 1 away from x to the power of 3. And what do I have left? I only have 2 of them left. That comes from saying 3 minus 1. My final answer, 2 remains 2, x to the power of 2, 3 remains 3, and y remains in my denominator. I'm not allowed to bring it to the numerator. It remains in the denominator. Right, and then let me just quickly show you number A, and that wraps up our discussion for today. Number A, we can see, okay, great. There are some signs there, there are powers, quite a bit happening there. So let's see. Firstly, a negative 20, x to the power of 5, y times z to the power of 3 divided by a negative 4, x to the power of 3, y times z to the power of 5. And here I also have divided by 10, x to the power of 2. Now, let's take that a little bit further. Okay, so what we are allowed to do here is we are allowed to simplify the first term. What do I mean, the first term? This fraction here. Altogether, we will have one term, but we need to sort out this part as well. But first, let's start here, okay? What I see is that I am allowed to say negative divided by negative is a positive. So the negatives cancel out. What I can do as well, I'm going to just blow this up a little bit for you. I'm going to cancel using these little strokes here. And what I see is 4 divides into itself, and 20 divided by 4 leaves me with a 5. And then I have x to the power of 3, x to the power of 5 at the top, 5 minus 3 leaves me with x to the power of 2. Y to the power of 1 divided by y to the power of 1 leaves me with 1. Y divided by y is 1. And what did we say in the first term? We said look at where the power is greater for your variable. Then you'll know where to leave a base. And here I'm going to say z to the power of 2 is left at the bottom. Now let me just refer that here. We have then 5 x to the power of 2 times, that's it, times 1. And we've already sorted out the 4, the 20, we've already sorted out the signs. We only have z to the power of 2 left in the denominator. Now what do I do with the division? I turn it into multiplication. I tip and times. And there's my 10x to the power of 2. And now I'm going to cross cancel. So let's do the cross cancelling. We are going to say 5 divided by 5 is 1. 10 divided by 5 is 2. X to the power of 2 divided by x to the power of 2 is 1. And what is left is the denominator. So really be careful to see what is left in your denominator and what is left in your numerator, okay, in that order. And what is left here is 1 times 1 at the top. And in my denominator, I have a coefficient of 2 and I have a variable of z to the power of 2. Okay, right. So hopefully that wraps it up for today when we look at our different examples of when we apply product or division. But we really had to pay attention to those rules of exponents, those rules with negatives to the power, and the rules with what is x plus x or x times x and the division. Okay, I hope that makes sense for today.